Now let's give a few examples a try. Please pause the video here and try to solve the question. Okay, now let's go through the answer. The following diagram shows a 4-volt battery joined to two resistors. So let's calculate the total resistance of the circuit, calculate the amount of current through the circuit, and calculate the current through the 2 ohm and the 6 ohm resistor. Okay, so the first one. The total resistance of the circuit should be quite simple. It's just two that are in series. Therefore, the resistance, it will be equals to 2 plus 6, giving you 8 ohms. Now, calculating the amount of current through the whole circuit, you need to use the formula which you learned earlier. V equals to IR. You have V, the potential difference across the battery, and you have the total resistance in the circuit. So, the current flowing out of the battery going through the full circuit is I equals to V over R, which is equals to 4 divided by 8, giving you 0.5 amperes. Next, calculating the current through the 2 ohm resistor and the 6 ohm resistor. This is a trick question because you should know that the current going through a series circuit is the same at every single point in the circuit. So, without calculation, we can just copy the previous answer, 0.5 amperes. Through the 2 ohm resistor, it is 0.5 amperes. Through the 6 ohm resistor, it is also 0.5 amperes. So now let's try this one. In the parallel circuit, calculate and solve the rest of the questions. Please pause the video here and try to solve these questions. Okay, now let's go through the answers. So the total resistance of the circuit would be 1 over R is equals to 1 over R1 plus 1 over R2. 1 over R total is equals to 1 over 1 plus 1 over 2. So 1 over R will be equals to 1.5. R, the final resistance, will be equals to 1 over 1.5, which is equals to 0.667 ohms. So these two resistors could be simplified into one resistor over here, which was 0.667 ohms. So now let's calculate the amount of current going through the 4-volt battery. We can do this by using the same formula, I equals to V over R, the voltage of the battery divided by the total resistance of the circuit, which is 4 divided by 0.667, giving you 6 amperes. So this means that 6 amperes of current is coming out of the 4-volt battery. However, the current through the branches need not be 6 amperes. Now we're going to calculate the current through the 1 ohm resistor and the 2 ohm resistor. So, if you remember the potential difference theory across a parallel circuit, the potential difference across the battery over here would be equals to the potential difference across the 1 ohm and would also be the potential difference across the 2 ohm. Therefore, the potential difference across the 1 ohm is 4 volts. So, we have V equals to 4 and R equals to 1. I equals to V over R gives you 4 over 1, and therefore the current going through the 1 ohm resistor is 4 ohms. So for the 2 ohm resistor, do the same thing. The potential difference across is 4 and the resistor is 2. Therefore, I equals to V over R equals to 4 over 2 gives you 2 amperes. 2 amperes is going through this branch. So this all actually makes sense because we previously learned that 6 amperes goes through the main, and now we have now learned that 4 amperes goes through this way and 2 amperes goes through this way. 4 amperes plus 2 amperes gives you 6 amperes. So the sum of the currents in the branches now equals to the main.